Okay, so for homework we had to solve a few. Nope, that's not it. Deal with it. There we go. We had to solve a few logarithmic and exponential equations. All right, so we're going to go through these four, and then we'll take a look at some others. All right, I'm just going to move this to the side. So the first one we had, we wanted to solve four times 3 to the x equals 20. All right, so our first step here, again, before we can do anything fancy with exponentiating or taking a logarithm of both sides, we have to make sure that the exponent part is alone. So the first thing we have to do is divide by 4. Okay, so when we divide both sides by 4, we get 3x equals 5. So again, the first thing you want to do is, can we break this down so that they have the same base, and then we just have to worry about the exponents? Well, 3 and 5 are both prime numbers. You can't break them down any further. There's no relationship. There's no common factors. So there's nothing we can do. So in order to get rid of this base 3, okay, we're going to use a log base 3 on both sides. Right? Remember, big part of solving equations, whatever we do to one side, we have to do to the other. All right, so through our properties, that gets us 1, and we're left with x on the left side. And on the right side, we're left with log base 3 of 5. Now, in the instructions, I told you to round to 3 decimal places. Okay, so you actually had to calculate this. So we could use our change of base formula. Right. So log base 3 of 5 is the same as the natural log of 5 over the natural log of 3, or the common log of 5 over the common log of 3. Both of those will get you the same value. Right. So natural log of 5 divided by the natural log of 3. Right. So rounding to 3 decimal places, we would get x equals 1.46. We'll say 5. We'll round that up. All right, so for your first problem, x is 1.465. Now, this is something we haven't done, but you guys should be doing. You know, shame on me for not reinforcing it, but we always want to plug back in to make sure things make sense. So I'm going to do 4 times 3 raised to the 1.465. And this is one thing I wanted to show you too. Because we rounded, we don't get exactly 20. Okay, as you can see, there's 20.00058, so on and so forth. All right, because I rounded my solution, that's not going to be exact. Right, this isn't an exact, oops, I wrote on my calculator. This isn't an exact answer, so we're not going to get an exact result. Okay, if for whatever reason I just said that this was 1.5, okay, if I rounded to 1 decimal place, okay, that's going to throw us way off. Okay, and that's almost actually 21. All right, so if you rounded 1.465 to 1.5, all right, that's a significant error difference, okay? Between 20 and 20.000581, I mean, that's, you know, obviously they're not the same answer, but they're close enough, okay? Up to 3 decimal places, they're close. But when I round differently, okay, that throws us way off, right? So we want to be as accurate as possible. And usually 3 decimal places is fairly accurate, okay? If, real quick, I'll show you, I'm going to plug in everything that I see. So 4 times 3 raised to the 1.464973521. That's super accurate. Okay, it's not exact because I don't have all the decimal points up there. All right, but that's pretty close. That's you know, arguably that's the same answer. Okay, that's the same as 20. Okay, so that was number 1. Number 2, we had log of 3x equals 2. So this one is a little more straightforward. Okay, there's more than one step though, so just be careful. Here, there's nothing outside of the logarithm, so that's the first thing that we're going to get rid of. Okay, again, this is our common logarithm. I don't see a base, so it's a base 10. So I exponentiate both sides. So sometimes I'm lazy and I just write the 10 like that, but I mean, you should be proper and write it like this. Nope, no. All right, but sometimes I'll just throw like the base underneath. So these cancel out. So you have 3x. Now 10 to the squared is 100. And then we divide both sides by 3. So again, we're going to get a decimal here, 33.333. If we round to 3 decimal places, okay, we get 33.333. That was number 2. All right, let's see, number 3, we're back to exponential. E to the 3x equals 12. All right, so again, there's nothing outside of that exponent part. Okay, so I want to get rid of this base of e. So to do that, we're going to use the natural log. All right, so we take the natural log of both sides. That eliminates our e over here. And for now, I'm going to leave it as ln of 12. So I have 3x equals the natural log of 12. And then we divide both sides by 3. Okay, so our exact answer is the natural log of 12 over 3. But to round that, obviously we have to type it in. So the natural log of 12 divided by 3. Again, make sure you close your parentheses if you're using a calculator. And that's going to be 0.828. Okay. And again, I'll just double check. E to the power of 3 times 0.828. And that's really close to 12. Okay, again, if I was more accurate with my decimal here, if I plugged in this whole thing, this would be extremely close to 12, probably like 11.999999. Actually, let's try it real quick. E to the power of 3 times 0.82830222166. What did I do wrong? Oh, there we go. Yeah. So the more decimal points I plug in, you can see that gives us a much more accurate answer of 12. All right, and our last one. All right, here we had multiple logs. So remember, when we have multiple logarithms, we want to try to combine before we can do anything. All right, so I can't raise any of these to the power of 2 yet, or with the base of 2, because I have more than one term over here. So because I'm adding 2 logarithms with the same base, I can multiply what's on the inside. So these two join, to log base 2 of x squared plus 2x. And this stays the same over here. Now that I have a single logarithm with base 2 on both sides, okay, I exponentiate. And we're just looking at what's on the inside. Okay, it looks like I'm going to have a quadratic, so I want to get everything on one side and set it equal to 0. So I subtract x. That gives me plus x. I subtract 6. Right? And now we're going to factor. So multiples of 6 are 2 and 3. That's positive, so that's going to be positive there. So I get x equals 2 and x equals -3. So let's go back, and we have to be careful because one of our answers is negative. Now, if I plug in -3 here, obviously that doesn't work. If I plug in -3 here, it doesn't work. But over here, if this was the only logarithm I was dealing with, if I plugged in -3, I'd have +3, which would be okay. So it works for this logarithm, but it doesn't work for these. So -3 is extraneous, and our only solution is x equals 2. All right, any questions about the homework?
We weren't supposed to put the exact values because you didn't ask for that, correct?
Right, correct. I mean, with this one, it's straightforward. You just get x equals 2.
Yeah.
Yep.
I was saying, like the other ones. Oh, okay. Thank you.
Yep, the decimals are good. If you gave me an exact, so if you typed out, I don't know, what was it? I don't think. So for number 1, you could tell me, log base 3 of 5 or ln of 5 over ln of 3. Both of those would be exact answers. But right, I wanted the decimal. I wanted that. Any other questions? All right, so we're going to take a look at 1 or 2 more examples. We'll see how much time we have. Okay, that look a little crazy. But once we break them down, we'll see they're not too bad. So I'll just continue from yesterday's notes. We left off with 3, so I'll say 4 here. All right, so we want to solve e to the 2x minus 3 e to the x plus 2 equals 0. So there's a few things going on here. This is our first problem, I think, where we have 2 exponential functions. Okay. So now, if we had the same base, we can look at the numerators, right? But that's only for multiplying or dividing exponential parts, right? We don't have anything for addition or subtraction. I can't combine these, okay? Especially because they don't have the same exponent. If this was e to the x and that was just e to the x, then that would be like, 1x minus 3x, and I can combine terms like that. But because our exponents are different, okay, I can't use that method. What I can do, though, okay, is I can rewrite this part as e to the x to the second power. Right? Those two are equivalent. When I raise a power to a power, we just multiply. So here I kind of went in the opposite direction and I separated it. So this might start to look like a somewhat familiar form. Okay, but I'm going to do something real quick. Let's say some other variable y is equal to 3 e to the x. So I'm substituting y in anywhere I see e to the x. So if I substitute y, here I would have y squared minus 3y plus 2. This is just a normal quadratic equation. It only looks funny because we have exponential functions in it. Okay, but if we replace those exponential functions with a single variable, we actually get a quadratic. So your first step in solving quadratics is always to try to factor it. Okay, so I'm going to separate them. Now, for now, I'm going to stick with y's, but then at the end, we can just go back and we can substitute back in. So two numbers that multiply to 2, well, there's only 2 and 1. Now, this is positive, so they both have to be positive or negative. And this is negative, so they're both going to be minus. So now that I have it separated like this, I can go ahead and I can substitute back in the e to the x. Okay, so all I did was I used this y as a placeholder for e to the x to make things look a little neater. And then once I had everything organized, okay, we substituted back in, we swapped back in. All right, so these are the same. I'm just using the y instead of e to the x because I know just from the past that's a little confusing seeing it like that. All right, but you could just jump from up here to down there once you're familiar and comfortable with working with exponentials. All right, now we just solve this like we would any normal one. So with this part, I get e to the x minus 2 equals 0. And with this part, I get e to the x minus 1 equals 0. Here I would add 2 to both sides. Here I would add 1 to both sides. And now we need to get rid of the e. So I would take the natural log of everything. Right, so here I would get x equals the natural log of 2. All right, I'll calculate that in a second. Here I get x equals the natural log of 1. This is one of our properties. The natural log of 1, any logarithm of 1, is always going to be 0. All right, so that's an exact answer. We can keep that 0 there. Now, if they wanted an exact answer, you're going to leave it like this. If they want you to round, you're just going to type in the natural log of 2. Oops. Natural log of 2, which we'll say is about 0.693. Okay, x is approximately 0.693. All right, so there we get our 2 answers. And for exponentials, we don't really have to worry about plugging back in to find extraneous solutions because our domain is all real numbers, right? I can plug anything into x up here. There's no restrictions. So it's okay that I got 0. It's okay that I got a low decimal. Even if I had a negative, that would be fine. All right, any questions there? So I believe that's yeah, it's about as tricky as it's going to get for now. I'm just trying to look for maybe one more example we can do before it time's up. You right over there? I think that'll be it for today. All right. Any questions or concerns?
What did you say? Give me a second.